Pictures over there too. Make sure you're getting them. Make sure you're getting them set up right.
So that's yeah. I tried, but I have no idea what.
You talking about the worksheet?
Yeah. I just didn't know where to start.
On which one?
Like Max plugged it into his calculator and got that, but I ended up I didn't know.
We just had it.
Yeah, that's what I was trying to.
All right. So Seth, in his infinite wisdom, had a great idea about moving the quiz to Tuesday. If you don't like that idea, blame us. But yeah, I think we're going to do it. Now, that does mean on Monday we will be going on to our next new thing and spending some time with that. That is not going to be part of the quiz, but that will allow us to, review anything at the last minute if we need to, or whatever on Monday, and so forth. So now I don't know if there's something going on Tuesday that'll make people have to miss too. I mean, I know there's a JV track meet. It's golf.
Yeah, I'm now on JV golf. So
What happened on that second night?
It was ugly. 15 hole 11.
15. We'll just start calling you Sergio.
Yes.
Did you see it? Did you see him yesterday? On which hole?
11.
Oh, that's a hard
11 out of bounds.
Yeah.
That's a play.
I hit 4 into the hazard. Realizing there's a drop zone.
From the tee box, you hit.
I hit one like into the grass stuff.
Right.
And so then I
straight
dropped
ahead.
on a hill. I took it as a lateral. So
There was a drop area
area
beyond the other side.
So I should have had a 6. Would have given me a 9. Still like great.
Yeah. Okay. So anyway, so now so there's a meet on Tuesday.
Yeah.
Okay. All right. Well. So anyway. But now so we can talk about that if you want to come in the morning and make it before you go or something. There was a JV track meet, but I wouldn't think any baseball on that. That wouldn't happen to. I don't know, Jack. You after yesterday, you on JV? No, you didn't do that. You didn't have a problem like that. Okay. All right. I didn't see your time. Looked like you ran. All right. Anyway, so let's talk about this worksheet here. Again, remember the key elements of this is this form right here, right? I mean, getting the parabola, recognizing this. I mean, x, whichever variable's to the first power, the one that's not squared, right? We want over here. We want the one that is squared. We want to complete the square if we need to get it to look like this. We need whatever constant or whatever is multiplied by that represents the 1 over 4p. If we can get it into that form, then everything else becomes easy after that. Then p is this distance here. Of course, if it's x that's alone over here, then it's horizontal. If it's the reverse of that, if it's y that's, if y is the one that's over here like this, and the x is the one that's squared, then it's a vertical scenario. But p is this distance, the directrix p units away, and we can just, the axis of symmetry goes down the middle, right? So really the secret is getting it into this form. Once we can get it into that form, we can have everything we need. If we know the focus, the directrix, those kind of things, then we can just plug those numbers into here to get the equation. So those are the two main things. Also understanding that the x and the y represent all the other points that are on the parabola. HK is the vertex, but XY is all the other points. Okay, so with that said, what questions did you want to talk about on the worksheet? Charlie, you said you had something. How about on the circle side? Anything on the circle side?
How do you do like 14 and 15?
14 and 15, let's look at those. Now, yes, I did add 3 IXLs. That's another reason to maybe postpone that. 1, 2, and 3 are parabola IXLs. Mrs. Payne, I think, thought you guys already knew about those at some point, but whatever. Those are, 4, 5, and 6 were about circles. 1, 2, and 3 were about parabola. Okay, I don't think they take a real long time. But those are ones that, again, can be good review before the quiz. So let's look at these bottom sections. So one of the things we did talk about with conic sections is that if you take a plane and you just hit the very top of the cone, then you got a point where it intersects. If the plane runs right down along the side, you have a line. Or if the plane cuts right down through the very, very middle of this thing, you have 2 intersecting lines. And those were called the degenerate cases of the conics. And so that's what they're looking for here, a circle, a point on the circle, or an empty set. And so basically it just means get it into standard form. I mean, really, anytime you get one of these equations that looks like this, your goal would be to get it into the standard form of that. Now, since this has both an x squared and a y squared, right now we identify that to be a circle, right? We know right away we see that, that's a circle. Now, later on, we'll get into ellipses, hyperbolas, and then we'll have some other possibilities there. But for right now, it's got to be a circle. So we just need to group our terms together. So we have x squared minus 2x and leave a blank. And we would have y squared plus 5y and leave a blank. And then we would have our 10, which we could leave there or move over to the other side. Probably should move it over to the other side. Okay? Well, once you do that, now you can complete the square. So what's going to go in the first blank here? A 1. Half of negative 2 is negative 1. Square that is 1. Okay? And then half of this, 2.5. Square, now you can do it with fractions or decimals. I'll do decimals this time. 2.5 squared is 6.25. Now, what do I have to do when I add those in there? Either add them to the other side or subtract them from that same side. I'll go ahead and add them to the other side. Plus 1 plus 6.25. Okay? Well, so what do I have now? I have x minus 1 squared. I have y. Tell me what I have here. 2.5. Remember, it's whatever you took when you got half of that b term. And then what do you get over here? Here's how you know what it is now. Because what is this side supposed to be? This is the center. What's supposed to be here? R squared, right? Well, can R squared ever be a negative? There's no way. And so that'd be an empty set. There are no points that are going to make this work. Because think about it. This thing squared plus this thing squared, those have to be positive values because you square them. So this squared plus this squared can never equal a negative. There's no way. So there's no points that make this work. And so that's why that's an empty set. Okay? And I believe what will happen on this other one is you get x squared, minus 8x plus a blank, and you get y squared plus 8y plus a blank, and then you put your negative 32 over there. And now what are you going to get when you complete here? 4 squared is 16. 16. So over here we're going to add 16 and add 16. Right? And so what do we got? We got x minus 4 squared. We got y plus 4 squared equals 0. So what's happening? You have a circle of radius 0, which means you have just the center, right? And you just have a point. That's just a point. So, circle equation where you just have a negative over here with the empty set can't happen. You have 0 over there. That's a circle with radius 0. That's a point. And then, of course, any positive would then be a circle. Okay? All right, and it is important to be able to do those. I mean, because that could show up on the quiz too, just some of these kind of things about that. The vast majority of the stuff is about standard form, drawing it, writing the equation. That's the main purpose, but these other things are important. Okay, what about the other side? So now the prep. Yeah.
Can you just do like number 5 for me?
5, determine the,
I really forgot how to do it.
so like, okay. Center, where are you looking for the center?
Would that be the 2 and the -2?
Exactly, in which order, what's the x?
-2 and 2.
Perfect. And what's the radius?
It would be 4, wouldn't it?
It's that number, this number is r squared.
Okay.
So the r would be,
Okay, that's a lot easier than I thought it was.
yes. Yeah, you were making it, you were complicating it, right? So on 6 and 7, the goal is to get it in standard form, right? Which we just did on 14 and 15.
Yeah.
And then you have your center. Yep, that's it. Yeah, that's it. Don't make it harder than it is. All right. Good luck this weekend, Alan. Stay warm. Yeah.
One of the final call at noon.
Is that what's happening? So you're good to go? So you might be back for the second half of class?
Not sure yet.
Okay.
Bye, Golly. Bye-bye.
Like Alex.
It wasn't that simple.
All right, other side.
Snowing. Okay.
Parabola side. But you're not playing today at all, right?
No, we're going to stay overnight because.
Right. Okay. Why are you going at 12:15?
I don't know. They want to have fun, but.
I guess, you're right. I know.
The soccer.
Why not?
Have fun.
But then you miss this class, so you miss all that.
Not fun.
All right, other side. Parabola side, parabola side, parabola side.
Number 3.
Number 3. Okay, so, and we're gonna do a practice one here again, but you've got to have a 1 in front of the x squared when you're going to complete this one. You've got to have a 1 in front of it. But if you've got the equation set equal to 0, you can multiply or divide both sides by any number you want to get it, right? So when you see a 1/2 in front of here, what would you like to do to both sides? Multiply by 2. So you would turn this into x squared plus 10x plus 16 equals 0, because when you multiply the other side by a 2, 0 times 2 is still 0, right? So we want to get it like that. So now we've got x squared plus 10x plus a blank, and then move the -16 over to that side. Okay, now this is actually a review. This is actually just solving. This is algebra 2 stuff. This isn't circle stuff, but it's the same technique. Okay, so what number do we need in the blank? We need 25 in the blank. Half of 10 squared, and then we need 25 to the other side to balance it out. Okay, and so we're going to get x plus 5 quantity squared equals 9, -16 plus 25. And then the whole purpose of this was to then, now that you have that squared on that side, you can now try to isolate the x by doing the square root of both sides. So when you get x plus 5, you get plus or minus 3. You do the square root of the left side, and that equals plus or minus 3. Because otherwise, you could not get the x by itself. In that original problem, you can't get the x by itself. Here's a way to get the x by itself. Now when you subtract 5, you have -5 plus or minus 3. So that would be -2 or -8, right? -5 plus 3, -5 minus 3. Now, we all know the quadratic formula. Could have done that from the very beginning, plugged those in and done the quadratic formula. Keep in mind, and you may or may not remember, but the quadratic formula is simply taking this equation and doing this to it, right? You divide everything by a, and you get x squared b over ax plus c over a equals 0. You would do the same thing we just did there, right? You would divide everything by a, and now you would do this is so much fun, I'm just going to do it. Now you would do, right? I mean, think about this. What's half of b over a? Well, how do you make a fraction half? I think I told you this earlier. What's half of 1/3? What's 6? You just double the bottom number, right? You double the bottom number, you've taken by half. So we take half of b over a is b over 2a, and you square that. That's b squared over 4a squared. So this would be b squared over 4a squared is what we want to do. You take half and you square it. Okay, this side's going to have negative c over a, and then it's going to have b squared over 4a squared. Okay, and so now what is this side? This is x plus b over a, quantity squared, right? Because whenever we took half, when we took half of that, that's what goes in our thing here. And then we got this. Well, we got to get a common denominator. Okay, so that has 4a squared. This has the a already. What's it need? What's this bottom need to be a common denominator of that? It needs a 4 for sure. And it needs what? Well, yeah, how do you get the square? It's got 1a. Need another a, right? A times a. So this needs a 4 and an a squared. So I'll take the top or the bottom by 4a. I'm going to take this times 4a. So that'll become 4ac. Oh, 4ac. Okay, so now I can put that together as, I'll write that as b squared minus 4ac, and then all over 4a squared. That's looking more and more all done. Now I'm going to square root both sides. I got x plus b over a. Oh wait, no, I did this wrong. What should this be? Not b over a. This should be what when we took half of it. This should be b over 2a. B over 2a. Equals plus or minus the square root of this. Well, it'd be the square root of the top, which would be square root of b squared minus 4ac. And then it'd be the square root of the bottom, which is just 2a. Right? And now what do? We subtract this over. And so we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Put that into one fraction. There you go. Didn't you do that in algebra 2?
I hope not.
I'm sure.
I hope all we did was, I really don't.
Well, remember we were in honor about it too, not out.
That's true. Yeah. Here, you get
I don't remember what I did last meeting. I don't remember.
All right, and then you just put those two together as one fraction, negative b plus or minus square root of b squared minus 4ac all over 2a, right? That's the quadratic formula. That's where it came from. So it was just completing the square, just taking the general quadratic, completing the square. That's all. Where it came from.
You should like erase the whole that.
All right, there we go. So, anyway, I know Mrs. Andrews. Yeah. So, and you probably gave the same reaction like that and forgot it the next time. All right. Okay, Charlie, so what went wrong on these? Some of these are written too, they're too easy. That's what happens. You're looking for all the completing the squared stuff. So like on this one, what do you need to do on this one? To get it into that standard form. You need to add the 3 over with the y, right? It seems kind of counterintuitive. Normally we want the y by itself. You need to get that over there so you have this, right? You want the x, the squared thing on this side with something multiplied by it, and you want the one that's not squared over the other side, right? Well, you're done. I mean, that's it. What's the vertex? What's the vertex? 0, negative 3. And now you need to figure out p. So 1 over 4p would be the 2. Right? This is now if you want to, we could have written this 2 and then x minus 0 squared. That's what I mean by it's too easy. Without having a number there, it just didn't, the 2, maybe you weren't sure that was supposed to be the 1 over 4p, but that's what it is. Right? So 1 over 4p is 2. We say if you get a whole number, just make it 2 over 1, and now you can cross multiply. So you get 8p equals 1, so p would be 1/8. Right? P would be 1/8. So once we have that, and now you can just go off to some corner of your paper, and what is this? What kind of parabola? Up and down or sideways? Up and down, right? Because it's x squared. Okay? Well, if it's at 0, negative 3, and it's an up, then that means you're going to go 1/8 down here for the directrix, and you're going to go 1/8 this way for the focus, right? So the vertex was 0, negative 3. The focus would be what? 0, negative 2 and 7/8, right? You went 1/8 that way, so negative 2 and 7/8. Your directrix would be y equals negative 3 and 1/8. And your axis of symmetry is what? X equals 0. And then it says, and the direction the parabola opens. I guess that would be up. Right. And that's it. That's it. And so the same, like number 7, well, this one, again, same thing. The 2, just move it over. The negative 3 would be the 1 over 4p. Here, move the 1 over. And there's a 1 in front of the y squared. That's the 1 over 4p. This one, you should flip those around probably. Flip those around and divide that 2 over there. So you have y plus 2. And then on this side, you'd have a 1/2 and an x minus 1 squared. So there's your 1 over 4p right there. It's a 1/2. Okay, and you got your vertex there. I'm not sure why. That's okay, it doesn't matter. Here you got to complete the square, okay? Let's do one. Let's talk about 11 real quick, and then I'm going to give you one to practice here on your own, okay? So let's look at 11. We got to get that in standard form. Now, here you cannot. So what's in the way? What's bothersome right now? The 3 is in the way because we want to complete the square on those x's. The 3 is in the way. So what can we do? Factor it out. You can't divide by 3 here because then you end up with something over here that you don't want. I mean, I suppose you could because everything here divides by 3. You could have a 1/3 y, but then you're going to have to do something with that anyway. But you could do that. You could do that, but I think factoring out the 3 is probably better. So let's try it both ways. Let's see what happens. Let's factor out the 3. Because this is the reason I'm hesitating is this is something I showed you earlier when it came to completing the square that we had to be careful on. So I just want to make sure we're okay with that. All right. So I better kind of leave a blank here, right? Because what I'm going to do is I'm going to add and subtract here at this point. So what would I like to be here instead of this 3? Let me scoot. Matter of fact, I probably should scoot that 3 over. Okay, I probably should scoot that 3 over. And so what I'd like to do is take half of that, which is 2, and squared is 4. So I'd like to have a 4, but then I need to take away a 4, right? So we really need to do that inside the parentheses there. Otherwise, we've kind of messed around with this thing. So that's why it all needs to happen inside there. Okay? So now we got to, but this is where we got to be careful. So to be honest, maybe dividing by 3 would have been the best, but let's just let's see if we can figure it out. We got 3, and then I'm going to have these 3's going to be what? X minus 2 quantity squared. And then what about those 2? They make -1, obviously, right? They make -1. So what should I put right out here? -3, right? These 2 make a -1 in the parentheses, but there's this 3 out here that has to go with them. So those make a -1, but the 3 there makes that a -3. And so it's going to end up being that. Okay? Now, I could have kept the 3 outside of all of it, right? I mean, again, this is where you just got to be careful with what's going on. I could have kept the 3 outside of all of this, and then I could have done x minus 2 quantity squared minus 1 like that, right? And then I could have said, okay, that's going to be y equals 3x minus 2 quantity squared, and then it's going to be a -3. So I could have done that, right? Now, let's do this in red. So one of the things I thought somebody might say, but didn't, if I divide everything by 3, that would be 1/3 y equals x squared minus 4x plus 3. So I could have done that. And then I'd have had 1/3 y equals, 1/3 y equals, now I'd have to complete my square over here, right? So I could add let me scoot that over. Okay, so see what this would look like. So I'll scoot over my +3. So I want to add a 4. now I could add a 4 to this side to balance it, right? So let me back up here. So now I could have had 1/3 y plus 4 on this side, and I could have had x squared, or excuse me, x minus 2 quantity squared here. I still got that 3, so I could subtract that 3 over here. I get 1/3 y plus 1 equals x minus 2 squared. Okay? How we doing? So I divided this, right, by 3. I got that, so I wanted to add a 4 to there, add a 4 to there. I got this, I had a plus 3, so I subtracted. Here's a plus 3 right here. So I subtract that 3 over, I got this. Okay, is that looking the same as this right here? What do I need to do with this right here? I need to put this 3 over here, right? Right?
Yeah.
Because I got to get this in standard form, so I'm going to put this 3 over here. I got y plus 3 equals 3x minus 2 squared. Now what do? Actually, I'm done, aren't I? Okay, so what do I need to do yet on this one to get done? I need this to be just a plain y, don't I? So what do I want to do? Multiply both sides by 3. So I end up getting y plus 3. And then over here I multiply this by 3. And I get x minus 2 quantity squared. And I get the same thing. So, you got to look at that. You got to think, okay, which one makes more sense? And you can't answer neither. You got to pick one, right? So factoring out the 3 and doing that way might make the most sense, because we do want to keep that 1/4p, this number here, with the squared. So leaving it on that side, factoring out and leaving it there might make more sense than dividing it over, because by dividing that 3 over, I ended up having to multiply the 3 back over again anyway, right? So maybe it does make more sense to factor that out. Okay? So again, I think I said this 2 days ago, sometimes, or potentially, the more troublesome ones are the ones that are just more complicated to get it into standard form, and that's just purely algebra. So you gotta work with that. But there's partial credit, right? If you needed to do one like this and you messed it up and you got something that was standard form, but somehow you had a number wrong, well, that's going to throw off your P, or it's going to throw off your vertex, it's going to throw off a lot of your answers. But if I can follow your work, and I can see, well, just this one little mistake right here, everything else was good, you're going to get a fair amount of credit from it. Yes?
Can you solve the rest of it?
It was, yeah. So, did you get that far, or are you just saying to make sense from that?
I was going along with you, and then.
Okay. So we had this.
See if I got the
right. So we had this right here, right?
Yeah.
So this is what we ended up with. Okay. So the vertex would be
2, -3.
2, -3. The focus, well, we can't do that until we get the P, right? So 1/4p would equal 3, right? Cross multiply, 12p equals 1. P would equal 1/12. Do a quick sketch. What kind of parabola is this? Up, down? Vertical, right? So 2, -3, so 2 -3's down here, and it's going to go up. So if P is 1/12, we're doing that. So it's going to be at 2, and it would be what? -2 and 11/12. The directrix would be down here, y equals -3 and 1/12. The axis of symmetry is right through there at x equals 2, right? Okay, that's the idea. All right, so let's go ahead and let you do a couple of quick ones here with circles and parabolas. Do circles first here. I just put the answer up here now. Okay, there's the answer. a look here. So, now your work might not look quite like mine. We'll talk about that a little bit. But you should have got that equation at the bottom, I think. Anybody agree? So a few people do. Okay. Well, we can't all be wrong then. Now we've had quite a few of them here in a row that have all been opening up parabolas, so just make sure you pay attention to that. So here I decided. So what was my thought process on my algebra? And I showed maybe more steps I need to, and some of you, I'm guessing your algebra look different than this. My thought process was I wanted to leave the x squared on this side because I like, when I'm going to complete the square, I want it to be positive in front of the x squared. So I wanted to leave that there. So I left that there and I moved these over here. But then I flipped it around because I knew I want the x squared on this side. So I flipped it around. Then I decided what?
Shouldn't the x squared plus 9x be x squared plus 6x?
Gosh, dang it, then how did that one, you guys agree with me?
I did.
Oh, yeah.
We can do your math.
I screwed up twice and ended up canceling each other out.
Wait, what?
Yeah, well, right here. I did two stupid things, and two stupid things make a really smart thing. Right here.
Nice. That's what me and Charlie
Yes. Right here, yes. Take out a 3. That should have been a 6. Okay? And that should have been a 6. So somehow in my pea-sized brain, when I divided here and I got a 9, and I should have got a 6, right? And then and this literally is what I must have been thinking to myself, okay, now let's take half of 9, oh, that's 3, and then square it. And then square it makes 9. And so somehow I strangely got the right thing. So yes, that should have been a 6. That should have been a 6. All right. So, anyway, so I did get the right answer. You're right. But, so, now I'm kind of scared to even tell you my thought process because obviously it was kind of stupid. But, so when I got to here, now the other time I told you not to divide by 3, right? I said that might be better to factor it out. Well, here's why on the last one, because if I divide by 3, I had a y over there. If I divide by 3, then I got 1/3 y, which I didn't really want to mess with. I didn't want a fraction. But I noticed that all of these are divisible by 3, right? So this time dividing by 3 would be a smart thing because then you don't get any fractions and then you're ready to go. Instead of have to factor out. But if you did, it'll still work. It'll still work when you factor it out, okay? So that's why I decided to divide by 3. Then I get to here, add 9 there, add 9 there, take out the 8, whatever. So I get 1/4p equals 1/8. Cross multiply, 4p equals 8, 8p equals 2. And away you go. Okay, but the algebra there is probably the biggest part of that. Okay, let's do a quick activity here. We've got a couple of those we'll do today. Get a partner, get a bag here. What you have is you have some, they're color coded, so you got to put the color coded ones together. What you have in this equation, like right here is a pink equation. It says x squared plus y squared equals 25. It's choice C, I guess it is. And then the other pink cards are all circles. And you take and you match. Oh gosh. You match the circle with there's 3 choices, like an A, B, and a C. So for each one of the circles, you match the one that goes with it. So like for answer 1, you'll either have an answer A, B, or C. For answer 2, you'll either have an A, B, or C. Whatever. All right. So each pair needs to grab a set of those, and each group will need an answer thing to put your A, B, or C by. Okay. So each equation is numbered. Right? So number 1, you get that equation, then you match the circle to go with it, and they're color coded. Okay? So everybody needs a. Oh yeah.
Yeah. Oh, that's great.
And you just need 1 sheet for your group. There's probably enough if somebody wants to work alone, or if you want to. I mean, otherwise a group of 2 or 3, maybe 3 at the most. If you want to do a group of 3, you could.
Charlie, what?
Put your names on your little slip.
I have a question.
Yes.
So, I'm not really sure. I think what I did is I factored out the 3 there, got that, and I divided by 9.
Well, you lost your X here, though, is what happened. See, here you have an 18X, and then here it's just an 18.
So that should really be like a 3.
So, well, right. Which you don't want to factor out the 3X, right? So you could, yeah. So you could have factored out a 3. And you got x squared plus 6x like that. But then you got to leave space, right? So when you get, see, that's not x plus 6 squared, though. That's your problem. See, over here you got 24y minus 3. Okay, but that's not x plus 6 squared, because x plus 6 squared is x squared plus 12x plus 36, right? You got FOIL, right? See, that's where you're going wrong. So if you'd have left that x on there, right there, right? Now you could factor it out like that. Now you can take half of that as 3. So that'd be plus 9, and then a minus 9. So now what you have is 3. You have x plus 3 squared, right? That's this part, the x plus 3 squared. And then you got a minus 27. Because 3 distributes. Now over here you got 24y minus 3. Now you add that 27 over there, you got 24y plus 24. Right? Then you take out your 24. Right? And then you got divided by 24. Now you got y plus 1. 3 divided by 24 is 1/8. X plus 3 squared.
Okay, so, no, you have 5 circles and 5 equations.
Okay, that worksheet, make sure everybody gets a worksheet before you leave up here, that 10-2, 11-2, both sides are due on Monday, okay? Don't forget about the IXLs also.